Attention pour le décompte final.
Final countdown.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage, décollage. La trajectoire est normale. Tous les paramètres à bord sont normaux.
Well, Vega lifting off perfectly from French Guiana, and right up she went rapidly in the light rain.
Acquisition de la télémesure
Don't
lanceur
know what
par la
kind of
station de
visibility
Saint-Jean-du-Maroni en Guyane
Enrico had
française.
out there. It looked like we lost Vega to the clouds pretty quickly. But she's beginning her second mission a little over a year after her successful first flight. The DDO is calling out all is fine, all is normal on board. 137 tons at liftoff. Ariane 5, you might recall, weighs over 6 times that much. Those of you who are familiar with the Ariane flights know the heavier launcher rises much more slowly than Vega. You saw Vega rise like an arrow, surprisingly quickly if you're used to watching Ariane lift off. Anyway, we were supposed to go, by the way, last Friday. We were technically ready, but we're held up by high altitude winds. But as you can see, we lifted off successfully.
La trajectoire est normale.
Tonight, all is normal on board. Basically, what's ahead?
Le pilotage est calme.
Vega's first 3 stages rise very rapidly in about 6 minutes. We're into the first stage burn. The first stage will burn another 20 seconds, flame out at about 1:55. The second stage will then ignite and separate at plus 3 minutes and 39 seconds. The third stage will ignite at 3 minutes and 55 seconds and separate at plus 6 minutes 18 seconds, and the AVM, the upper stage, will take over then.
Séparation du premier étage.
We've just had separation of the first stage. You heard the DDO call out. We have first stage weighing 97 tons, 88 tons of that fuel, all of that used up. We're into the second stage burn. And before we talk about the second stage burn, welcome back, Enrico. How was it out there?
Even if there were a lot of clouds, raining clouds.
You didn't see much, did you?
No, not very much. But it was magnifico, you know, because at the beginning you see a little spotlight on the launch pad. There is no sound. And it disappeared, the light disappeared, but then after there is a loud noise that arrives, the music of the propulsion that rolls you from the sky, and it makes you little vibration on your skin, you know, but
Goosebumps,
not little vibration, because it's a noise so high that it could seem an earthquake, you know. It's so
that loud.
Yes, that loud. It's.
So you're impressed.
Yeah.
Now you've seen. This is not the first time you've seen a launch.
It's the first Vega anyway. It's I've seen 4 Ariane 5 before, which they are noisier, but for the little Vega, it's quite impressive.
Super. So even with the loss of visibility early on, you still had a lot of noise. You still had an impressive side.
Yes, and this noise, it's a mark of the power of the propulsion. You know, it's and even if you don't see it, you can feel it.
Good. Okay. Well, if that doesn't make you want to come down and watch a launch, folks, I don't know what will. Enrico, back to work. Sorry to put you to work. On the upper left-hand side of the screen, you have the cursor crawling up a line, and below that you have 2 lines, A and V. Can you explain to us what those are?
Yes, yes. The curve is a theoretical path that the launcher has to follow to accomplish its optimized mission. And the little A means altitude of the launcher. Below it, you can see a V, and it's the abbreviation of velocity and speed. But on the curve, that you can see a little dot that is moving, and that dot is a current real-time position of Vega given by the data coming from the launchers.
All right, altitude 210 kilometers, speed 4 kilometers per second. Our top speed will be about 7.5 kilometers, so watch for that. While you were giving us that rundown, we had the separation of the fairing. You saw that, revealing to the elements probe V, which will be separated a little later on.
Mhm. Yes, the fairing is jettisoning
Tous les paramètres à
because
bord sont
outside
normaux.
the Earth atmosphere, the fairing it doesn't need it anymore, and so we lightened the launcher of about 550 kilograms.
We're in the third stage burn. The Z9, as they call it, the Z9, the 4-meter long Z9, though Vega's smallest solid
La
propellant
trajectoire
motor,
est normale.
has the longest burn time. She'll burn about 2 minutes, weighs 12 tons again. 10 of those 12 tons are fuel. So a lot of the weight
Tous les
of the
paramètres à
vehicle,
bord sont normaux.
like for Ariane, is propellant.
Yep.
Coming up on separation of the third stage, we have another minute to burn. Going back to the fairing, industrial team is a big one. Italian, Spanish, German, Belgian, French, Swiss, Ukrainian, and Swedish firms all participate in design and development of the fairing.
Yeah, and the fairing on ground maintains a clean room environment for the precise instrument of the payload, and probably as a very sensitive optical instrument.
And we can release it now, as you said, because we're out of the Earth's atmosphere, and it's designed to protect the satellite from movements and thermal.
They protect against the impact of the dense atmosphere.
And of course, we're out of the atmosphere now, so we don't need it. We're coming up on extinction of the third stage, and then we'll have ignition. First ignition of the oven. There's extinction. You can see it shutting off the nozzle. You hear the DDO call out the confirmation. You see our speed, and there's a separation of the third stage. Sometimes there's a second or two delay between the time the thing happens, the event happens up there, and the telemetry comes back here into Jupiter, which is why we get the animation a little bit first. But you see, we're doing well. The fourth stage has started its first burn. Fourth stage is called the AVUM, A-V-U-M.
Yes, for attitude and vernier upper mobile. Vernier referring to the thruster that are used for fine adjustment to the attitude or velocity of a spacecraft.
This is different from the lower stages, which use solid propellant.
Yes, exactly. This fourth stage is a liquid propellant engine, and it can be shut down and restart.
Basically, is it fair to say that solid propulsion, like on the first three stages, is used for raw power to get us going? And is it fair to say that the liquid propulsion is a little more sophisticated, used for precision?
Exactly, yes. Yeah. Because the AVUM is designed to deliver payloads into different orbits and to perform very fine satellites pointing before separating them.
We've been picked up by a downrange tracking station in Bermuda. Vega will pass over it twice. On its first pass, it'll see extinction of the first AVUM burn. Vega's trajectory has been designed to be followed from the ground at all times. The launcher, I should say, is sending back radar and telemetry to these downrange stations. Now, what's telemetry?
Yes, telemetry is the way we have to stay in touch with the launcher. The downrange telemetry stations receive electromagnetic waves that brings information, thousands of parameters and indicators of Vega health in flight, motor pressure, stage separation event, nozzle activation, and so on. We analyze some of this data in real time, so we know where the satellites have been released, for example. The other data are examined after the flight to find how the vehicle performed. We have downrange telemetry stations in most of the places of the flight by the launcher, Bermuda, Perth, Saskatoon, Lucknow, added to those in French Guiana.
Our altitude, 274 kilometers. Our speed, 7.74 kilometers per second. We're going to go shortly to a replay of the liftoff, a medley, I think, of launch replay shots from different places. You'll be able to see for yourself, once again, those good, very interesting pictures that took place about 8 minutes ago. We're following the second Vega mission. Here's the replay. What that made you recall the moments that you spent out on the balcony there? What went through your mind as you saw those shots?
It recalls my previous job in CNES. I participated to the design of the ground segment of Vega with the people of Esrin and Industrial as Vitrucizet. It was quite hard to answer to all the requirements of Vega, but now it becomes real.
The real thing. Avum carrying 626 kilos of propellant in her 4 tanks, powered by a restartable engine, as we mentioned, and we're going to have 5 burns on this flight. What do we need 5 burns for?
Yes, so the 2 first burns are necessary to target the 820 kilometers of the circular orbit of Probavi. You know, the following 2 are for the benefit of the orbit at 670 kilometers of Veneretsat and S-Cube. Then after, we have the 5th and last one, which is necessary to deorbit the Avum following a safe and predetermined trajectory over the Pacific Ocean. The space debris mitigation is one of the very important innovations of this launch.
I think on the first Vega launch, lasted just over an hour. Tonight's will be over 2 hours. And the Avum, at that time, we had 3 burns, and so now we have 5.
Correct, yes.
There are other differences, which we'll get to in a moment. But for the moment, we are in the middle of the first Avum burn, which will burn again for about another 30 seconds. Then we'll have a ballistics phase, coasting phase, which will last about 3/4 of an hour. Then the Avum will reignite for the second burn. It lasts about a minute and a half. They're short burns and they're long burns.
Yeah.
Shortly after that, Prova V will be separated at about plus 55 minutes and 26 seconds. Then there'll be a third Avum burn, and a 4th Avum firing will prepare the separation of Vinredsat and S-Cube. If you're looking ahead, Vinredsat separating at 1 minute and 57 minutes after launch, and S-Cube 1 released about 3 minutes. After that, coming up on the end of the first Avum burn, we should hear the DDO. There we go. She's called out the first flame out extinction of the upper stage, and you see our speed on the lower left is 7.96 kilometers per second. I think that's going to be about our top speed, because we're going to be changing speeds now.
Exactly.